Well, thank you, everybody, for being here. We are going to give you today an overview of Lightbits. For those of you who are familiar with Lightbits, some of this may be a repeat, but we'll go into more details around our solution, around the work we're doing with VMware, and then also give you a preview of Lightbits on AWS. So I will be starting off with the company overview and summary of Lightbits value proposition. Mark is going to pick it up to talk about VMware's view on all this. And then Ophir is going to go into more technical details and also tell you more about Lightbits on AWS. Now, let me just start. Quick company overview. Lightbits has been around for about 6 years now. We build high-performance software-defined storage for cloud infrastructure. And our focus is on building a solution that is very efficient, that is easy to use for cloud model, which means high scalability, agility, and it is targeting high-performance applications, low latency use cases. So that's our focus, is high-performance use cases. We invented a protocol called NVMe over TCP. If some of you may be familiar with NVMe fabrics, NVMe over TCP has been standardized as part of NVMe over fabrics. It's basically another transport option, something that we introduced and we presented to the industry, and then with the help of Facebook and Intel and others got it standardized. In 2018, it was standardized, and today there's a whole ecosystem that supports it, including VMware, and all the Linux distros have in-box support for NVMe over TCP. I'll talk about that in a second. We are focused on cloud infrastructure, whether that's internal clouds within enterprises or cloud service providers. We are going after the use cases that need the cloud model. And we have a number of strong investors behind the company. You can see Cisco Investments, Dell Technology Capital, Intel Capital, Micron. Back when VMware was part of Dell Technology Capital, actually, our partnership with VMware was a key driver for Dell to invest in Lightbits. So back to a question that was asked before, the partnership with VMware has been in place for several years, and it was one of the key motivations for Dell investing in Lightbits. All right, so the macro trend here is this digital transformation wave that has been underway for a few years now. And with that, there's massive amounts of data that companies are collecting, and not just collecting, but they want to extract value from this data. They need to store it rapidly, analyze it, and generate value from that data. Now, if you think about the underlying infrastructure that needs to support this, from a compute perspective, there's been significant amount of progress with new CPUs from Intel, AMD, ARM-based, lots of cores, lots of power there. Networking perspective, 100 gigabit Ethernet is a commodity. We go to data centers and they have plenty of network bandwidth available that is not used yet. There's plenty of headroom there. But from a storage perspective, there is still a bottleneck. There is no high-performance software-defined storage that can be deployed with a cloud model until Lightbits. If you look at what exists, you have, on one hand, legacy storage vendors that are providing solutions that were designed for on-prem traditional IT infrastructure, not really suitable for cloud model, and they tend to be hardware appliances. Or you have software-defined storage, which is lower performance. It's suitable for many applications, but not for latency-sensitive database applications or performance-sensitive analytic workloads. So that's where our focus is, to build simple and high performance, and also something that from a TCO perspective makes sense, storage for the cloud infrastructure. So it's all about delivering the enterprise features that you need for storage, but at high performance and on any server. And when I say any server, that means it can run on any cloud. By the way, when I say cloud, it's not just the public cloud, it's also internal private clouds, and also edge clouds. So any model that requires software-defined everything running on commodity hardware, same infrastructure supporting many different applications and different users, different tenants, that's what I mean by cloud.
Does it mean that in the backend you don't use NVMe to access the drives? Because not all the vendors, not all the cloud providers offer NVMe access to their, virtual machines?
We do run on servers that have NVMe SSDs inside,
So
not SATA or SAS.
Okay.
Only NVMe SSDs. And today, all of the server vendors have servers.
And cloud vendors have this.
Yeah, cloud vendors too. So if you look at AWS, Azure, GCP, they all have instances that have NVMe SSDs inside. Yes. So for example, AWS, we'll talk about in a second, our first offering will be on i3EN and i4i instances, which are Intel-based NVMe drives. And then we will follow with a Graviton-based, which is based on AWS's own ARM-based CPU, also with NVMe drives.
But not the Epic from AMD platform.
Initially not Epic, but eventually yes. So on-prem today, when you look at private clouds, we run on Intel and AMD. On AWS, we will start with Intel and Graviton, but eventually, our software runs on any x86 and also on ARM.
Do you take advantage of the Nitro architecture from AWS?
Yes, so the Nitro architecture provides improvements to the performance of the instances, and so
Like you do, with the accelerators available from Intel. So optimizations that allow you to use less CPU, for example, or optimize compression or whatever it is.
I'm not going to go into that level of detail today, but once we release our Graviton-based solution, you will see the optimizations that we do on top of Graviton. With Intel specifically, we announced already that we've been working with Intel since second half of 2020. They came in as an investor, and also we do co-engineering with them, and we optimize our software for initially Intel Ice Lake, and soon it will be available also on Sapphire Rapids when that is released, including taking advantage of acceleration, hardware acceleration that's available on the chip. With Graviton, I'll come back to that in the future.
I'm a bit bemused as to why you're going for Graviton before Epic, given Epic's got a much stronger growth rate of adoption generally. So it would seem a bit back to front.
Well,
or maybe
we are targeting Graviton for use cases that are more cost sensitive, and Graviton does have advantages there in terms of how AWS is pricing Graviton instances. And also through our partnership with AWS, they encouraged us to also support Graviton. We see ultimately this is a decision for our customers. We are hardware agnostic. We do lead with Intel because we have a very deep partnership with Intel, and through that partnership, we do not just joint marketing and joint customer engagements, but there's actual engineering work to optimize our hardware and software together. So we lead with Intel, but if a customer wants to run us on AMD or on ARM, we can do that too. And our AMD offering on AWS is just going to be customer driven. So if there comes a point where we're seeing strong enough of a business case to add AMD to the list, we can do that. It's not a very difficult thing to do.
Okay. You were speaking about x86, Ice Lake, and so on. Are you doing the same thing with Optane?
With what? I'm sorry.
Optane.
Optane?
Yeah.
We do use Optane, yes, for as a persistent write buffer, and as well as a storage for, not storage, but a memory replacement for metadata. Because our metadata, anyway, we're getting into the details of the architecture, but our software stack has a front end, which is the NVMe over TCP, and has a back end, which is an intelligent flash management software layer. And by the way, that is a source of a competitive advantage for us, because that software layer allows us to reduce latency and tail latency with respect to the media itself, and also improve endurance of the media. So that software layer creates metadata that needs to be put into memory, and so we use Optane as a lower cost memory there. Bottom line is we can run with Optane or without Optane. With Optane, there's additional price performance improvements.
And so the flash you're using, if you're using flash optimization, are you using a mixture of single, multi, quad level cells? Or?
Yes, yes. Most of our customers are using TLC or QLC. And because of our intelligent flash management, we can improve the QLC endurance by 5 to 20x. So QLC, if you use it just as a direct attached storage, is challenged when it comes to write-intensive workloads, not with Lightbits. Because if you get 5x or 10x or 20x improvement in endurance, now you can use QLC for any workload. Great questions, but let's keep going so we'll come back to a lot of these topics as we move forward. So very quickly, our software stack, again, runs on commodity hardware. We support different application environments, VMware, Kubernetes for containerized workloads, and then we have different deployment options. Today, our customers are running us on enterprise internal clouds, which I call private cloud here. Edge clouds, these are tier 2 CSPs. We have a number of customers in this category, and we are going to release our solution initially on AWS very soon, and that's the preview you're going to get today. Bottom line is what we provide is we are addressing this problem that high performance storage in the cloud, whether it's internal cloud or public cloud, today is very expensive and it's complicated. And that's exactly the problem, that statement that we're attacking with our solution. We provide a unified, consistent, high-performance block storage service across these different deployment options. We charge for what is used, not what is provisioned. And over time, this platform will add more and more management capabilities for tiering, for optimization of where data is placed, and migration of data across different platforms. So let me just take a minute and summarize the value proposition here. I want to make sure you understand how we're different than all the other solutions that are out there. The way we get deployed is very simple. We are a target-only solution. So we run on commodity servers that are storage servers without having to touch the network or touch where the application is running. All of these applications can get a high-performance block storage service through the Lightbits cluster. So unlike other solutions out there that require proprietary software on every single node, our solution only runs on the target side because we standardize.
Are you proprietary solutions on every node? Are you talking there about NVMe solutions, or are you talking about the other hybrid cloud data platform, storage platform options? Because it's quite a busy market now. It's quite a lot of cloud storage platforms.
So if you look at HCI solutions, they require software on every single node, right? Ours is a disaggregated model. Now what we're doing is we provide disaggregation, which means sharing this pool of storage across all your application servers, getting much higher utilization of that storage, which means lower cost, but at performance that's similar to local flash.
Essentially, you're providing a much more performant storage subsystem that performs as a storage subsystem, so it's independent of whatever else is going on.
Yes, and it runs on commodity servers. It's software defined. It's not a hardware appliance.
And then for the performance, presumably that's because it can leverage NVMe over Fabric and other.
Part of it, yes. Part of it is our NVMe over TCP connectivity to the compute nodes, but then the back-end management of the flash, the intelligent flash management, the end-to-end data path, which is designed for high-performance NVMe, is unique. So none of our competitors have that back-end flash management. And if you think about the latency, most of the latency comes from the media, not from the network itself. By the way, when I say latency, it's not just about average latency, it's tail latency. So because of our intelligent flash management, we avoid read-write conflicts, for example. We do large blocks of write instead of random I/O to the media. All of this means more consistent latency, which is absolutely important for example, database applications.
So who builds the actual servers? Can it be any OEM and you just send them on your software?
Dell, HP, Supermicro, Lenovo, they're all OEM partners of ours. Even if many of the cloud vendors build their own servers, we work with them too. So we're hardware agnostic. It can be Intel-based, AMD-based, ARM-based.
And the network required to support this? Do you need Mellanox or anyone else?
Vanilla TCPIP. This is not RDMA. So it can be Mellanox, it could be Intel NICs, it could be Broadcom NICs. As long as you have enough network bandwidth to put the storage on the network, you're good to go. This is the beauty of this is you can set it up and run it literally minutes. This does not require, if you had an RDMA fabric, that means your networking needs to support RDMA, all the NICs needs to support RDMA, and as soon as you start scaling, it's very, very difficult to get it to work at scale. It works great for like a few racks, but at scale, TCPIP, easy to use.
So you can pretty much fit this into most existing data center fabrics today.
Pretty much, yeah.
Any minimum
Any
port
of them.
speed, 100 gig, or will it work on 50, 40, 10?
You do need to have enough network bandwidth, right? Typically, we have 10 or 25 gig on the clients, and we have 40 or 100 on the targets. It depends on the size of the target. So if it's like a 1U server with 8 SSDs for each of these purple boxes, then 40 gig should be enough. If you have 25 SSDs or 32 SSDs, then 100 gig would be better. You just want to have a balanced design. So what we do, if a customer comes to us and says, all right, I want to use this particular server, we review the BOM, make sure it's a balanced design in terms of the number of SSDs, the number of CPU cores, the networking. You don't want to create any performance bottlenecks. And we give some feedback to the customer. We do qualify the server fairly rapidly, make sure everything's working, and then they have the green light. And by the way, in today's environment where you have a lot of supply chain disruptions, this is very valuable to customers to go to them and say, you know what, you can use any server vendor that you like, whichever one gives you better terms on lead time and pricing. And whereas if companies that have a custom hardware appliance, you're kind of locked into one particular hardware. And the other beauty of our approach is that as soon as Intel comes out with Sapphire Rapids, we're on Sapphire Rapids. As soon as there's a new SSD, we can support it because we don't have to spin hardware. We just need a server vendor that supports that hardware and we're good to go.
Is there any performance difference really between what makes the difference in a server in terms of performance in your system? Do you need more RAM, more CPU cores?
Well, they all kind of go together, right? So the number of SSDs, the CPU, typically we do single socket, dual socket, minimum 14 cores up to, as you scale the number of cores and the performance per core, then you could see the bottleneck shifting to somewhere else. It could shift to the networking side, for example. But we saturate 100 gig with a 2U 24 SSD server.
What is the minimum configuration of this solution in terms of nodes?
Oh, in terms of nodes, it's 3 nodes.
3 nodes.
So a single cluster. We're creating a cluster. Why do we create a cluster? Because it's an HA solution. If a single node fails, the data is protected and there's no interruption of service.
Okay.
We have 2 levels of resiliency. One is RAID across SSDs. So each of these boxes is running RAID across SSDs. And here's another differentiation point, that if an SSD fails, there is no activity across the cluster. It fails in place, and data is protected, no interruption of service. Whereas in many other solutions, a single SSD failing will cause traffic across the network. So that's one layer of resiliency. The second layer is that per volume, you can decide if you have 1x, 2x, or 3x replication. And that will protect against an entire storage server failure. So it's a clustered solution. It provides HA, and it's scale out. So as you add more nodes, you can get more performance and capacity.
So if you're using local RAID and plus regional coding or whatever for to distribute data protection, does it mean that you have 2 levels of protection, but also it's less efficient from the capacity point of view, because you lose like 20% for each node and then 20-30% again for distributed erasure coding or distributed.
There is you do have to provide raw capacity for its replication across nodes. So you can have, on a per volume basis, you can decide. When you create a volume, this volume is 1x, another volume is 2x replication, another volume is 3x replication.
You don't have erasure code, distributed erasure coding?
No. Distributed erasure coding across nodes is on our roadmap. Today it's synchronous replication. And the reason we started with synchronous replications, there's a few reasons, but first of all, from a performance point of view, It's much better as compared to distributed erasure coding. So we started with the high performance option first, and then we're going to add the lower cost option, which is distributed EC. And second, when you have failure of a node, you are limiting the number of volumes that are impacted, whereas with distributed EC, all volumes can get impacted. So there are some trade-offs between the two options. When we move to when we add distributed EC, it's going to be in addition to synchronous replication, because we expect most of our customers actually to continue with synchronous replication.
So this is a question to help me position the solution. I mean, okay, so from the performance point of view, you probably have better numbers than traditional players, NetApp, Pure, etc., etc. But general purpose, market, okay. So you are going to cost, in terms of dollar per gigabyte, much more than these guys.
Much less, actually. So we've done comparisons to traditional storage vendors, as well as some of the existing software-defined storage products. Now, if you compare us to DAS, direct attached storage, we're clearly lower cost because we get much better utilization of the flash. When you have direct attached storage, you end up with lots of stranded capacity and wasted capacity.
Yeah.
In this model, disaggregation, you get much better. So compared to DAS, we have equivalent performance, slightly higher latency, but very similar from an application point of view. It's indistinguishable, with much lower cost. Compared to the traditional SAN vendors, because we use commodity hardware, because we have higher performance, we can get to the same performance with fewer number of nodes. We get also lower cost.
No, but I am talking about not very high performance, and then you compare dollar per gigabyte. I'm talking about, a traditional VMware environment where 1 millisecond is still good enough, okay? Because 99% of the workloads are good enough with that. You're going to cost much more. So if I'm buying 50 terabytes of primary storage today with a NetApp or with a Pure Storage,
Right.
and they're already fighting, up to the last dollar to get, the customer. So how are you going to compete? On a latency basis, you are not going to win, because dollar per gigabyte is the first metric for every customer, except tier 0 applications. Okay. So I'm talking about tier 1, tier 2 applications.
Well,
are you
we only
there?
go after applications that require high performance. So if it's an application that can be addressed with mechanical drives or doesn't need high performance, it's not a target for us. You're right. We are focused on, number one, high performance. Number two, applications that require high scalability, so the cloud model. Okay? In that space, then we do have the best TCO. And we have models. There's actually a link on our website that does comparisons. So if there's a use case that needs millions of IOPS in a cluster, and latencies, average latency less than 500 microsecond, tail latency less than a millisecond, we shine. We have the best TCO within that framework. Now, if a customer doesn't need that performance, then that's not a focus for us. You're right.
So your direct competitor is Pavilion more than NetApps and
direct attached storage many of our customers initially have direct. Why are they using direct attached storage? Because they need performance, right? So they cannot get the performance they need from those alternatives. They use direct attached storage, and then they end up, as they scale, wasting a lot of capacity, and then they come to us. The other problem with direct attached storage is that when you have a failure, you have a lot of network activity, which puts pressure on the network, and long recovery times. And you don't get data services with direct attached storage unless you have some higher level of software. So we give them enterprise availability and features and a disaggregated model, which is much better utilization of your flash, but at performance that is equivalent to local flash. That is our focus. Now, sometimes I'll tell you right now, we're talking with a big hyperscaler that is looking at us for some of their native services. And they're saying that none of the storage partners they have today or their internal service that they offer today delivers linearly scalable performance at low consistent latency. That's why they're talking to us. That's why they're looking at us. And this is their own words, that none of their other partners can do that. Now, if it's a use case, you can have like 5 millisecond latency, and you're only concerned about cost, and you don't need that, you need a few 100,000 IOPS, well, that's not a good fit for Lightbits. Now, for this particular customer and others, this opens up a new set of applications they can run on their infrastructure that they couldn't do before. So this particular customer is saying that they cannot do latency-sensitive databases with their existing offering because of that reason. Because as they go to high performance, the latency just shoots up. So now there's a few other things. We talked a lot about performance, but this is a multi-tenant solution. A single storage cluster here can support multiple vSphere clusters and also Kubernetes clusters at the same time. This is exactly what CSPs want. They want to build storage clusters that are scalable, that are easy to deploy and manage, and all this virtualized storage capacity can be shared across multiple tenants and multiple application environments. Again, you look at HCI solutions, it's a one-to-one mapping between storage and the clients. Not so here. So this is, again, designed for the cloud. So the applications, again, this is what we were just talking about. Applications that are I/O intensive. So a lot of database applications, modern database applications, SQL, NoSQL, and analytic workloads that need high performance.
Is there any reason Microsoft is conspicuously absent?
So today, if you look at the NVMe over TCP ecosystem, which we've been working very hard with Intel and VMware and others to create that ecosystem, Microsoft Windows does not have support for NVMe over TCP yet. It will have support in the future. But today, all the Linux distros support it. VMware supports it. This is in partnership with Lightbits. And pretty much, the NVMe-based servers are available from all the different vendors. So it's going to take time to complete the maturity of this ecosystem, but we've come a long way. Microsoft is not there yet.
I would be focusing on partnering with them here in Europe in particular. They are by far the most strategic vendor for most companies across all of their IT infrastructure as well as databases, but they're also the fastest growing of the public cloud stacks being deployed in private IT.
The answer is yes. The answer is yes. I can't get into all details, but the answer is yes. We are working with Intel and Microsoft to drive the work with Microsoft. And by the way, if on the client side, if I go back to this diagram here, if there is an OS that does not support NVMe over TCP in box, there's two options. Either there are third parties that provide NVMe over TCP drivers, and that exists for Windows, for example, today, which we've also qualified those drivers. So that is one option for the customer to deploy that driver. Second option is to use a SmartNIC. And if you use a SmartNIC, you offload the NVMe over TCP initiator, and so the OS is not running the NVMe over TCP any longer. So even today, there are ways to address Microsoft.
And that also includes the new DPU class?
Yes.
As well? So,
yeah.
Okay.
Yeah. So either a software driver, which is a third-party software driver, or a DPU, some people call it DPU or IPU or SmartNIC, all the same thing.
Yeah.
And we have by the way, we have a very close partnership in place also. If you go back and look at Intel On event from fall of last year, their introduction of the IPU included Lightbits as part of their demo. They demonstrated how IPU works with disaggregated storage with Lightbits. So we're working with Intel on that as well. Now, this is a storage solution that can scale up or scale out. Individual nodes, you can add or remove SSDs. So if an SSD fails, it fails in place. If you add SSDs, you can dynamically add it, and the capacity is dynamically balanced across the SSDs. So you can scale up, or you can scale out by adding nodes. As you add nodes, you're linearly scaling the capacity and the performance of the total available performance of the cluster. And with that comes the HA model, where you place these storage servers in different failure domains, and our architecture is failure domain aware, so that, let's say, if the failure domain happens to be a rack, or it could be an area, or it could be a power zone, whatever it is, when this rack goes down, every volume that's in these two is replicated in other storage servers. No interruption of service, and of course the data is protected. Just want to take a second to talk about the intelligent flash management. This is a key part of our IP. We have a number of patents in this area. It's basically, in our software stack, you have the front end NVMe over TCP, but in the back end, there is if you're familiar, those of you who are familiar with SSD technology, it's a full global flash translation layer that takes all of this random I/O from multiple tenants, from multiple application environments, and creates from it these large sequential operations to the flash that are striped across all the SSDs. In the process, it also provides data services and supports the clustering. So what do you get from this? You get two things. You get better endurance out of the flash, because we are reducing the write amplification, as I said before, 5 to 20x. If you turn on compression, you can go up to 20x. Without compression, it's 5x is what we're measuring, which means now you can run your write-intensive workloads with QLC flash, or in the future, PLC flash. And second is the more consistent low latency, because we are avoiding conflicts between reads and writes and latency spikes that come from that. So as a result, you get much more consistent, low and consistent latency. You know, a lot of people focus on the network side when it comes to latency, but you got 100 microseconds just from the media itself. So if you can put the SSDs in their optimum place and avoid these conflicts that create spikes, the application is experiencing much more consistent latency.
I have a question about QLC. So do you support QLC and QLC on the same node, so that you write on TLC, organize the writes again, and then write on QLC? Because otherwise, if you are not having Optane as a staging layer, so how are you managing to put a lot of writes together to write on QLC without having the problem that if the power goes away, you may miss some writes?
So we can stage the writes. It's a great question. We stage the writes either in Optane, in NVDIMMs, or in DRAM. So if you think about the cloud, in the cloud, when a node goes down, you actually can never recover that node. Our software is hosted on VMs, basically. So it doesn't matter if you have persistent write buffer or not. If a node goes down, you lose that node. You cannot get it back. So our model is any of those can work. Optane, NVDIMM, or DRAM for staging.
DRAM means that you replicate the write on another node at least before doing the other stuff.
Yes, exactly. So the data is staged in our DRAM write buffer, but then it is only committed as a write after it is replicated in the other nodes, in the other
Okay.
failure domains.
So you are not supporting TLC, QLC kind of hybrid architecture?
Well, in a single node, it has to be the same, but across nodes, it could be different. Right? Correct me if I'm
Just
wrong.
from logical reason, not from the implementation. The implementation support different SSD types of TLC and QLC together, but it doesn't make sense from operation point of view to mix them.
And for the SSDs themselves, is it from a certified list that you support, or can it be almost anything?
We've tested Micron, Samsung, Intel now, SK Hynix. It can be any NVMe SSD, but we do test it in advance just to make sure, there's...
So there's a certified list of, say, part numbers people can choose from, really?
Yeah, so the way it works is we have a document that we call Lightbits Ready Storage Servers. That includes SSDs and the server itself from all the different vendors. And so we provide that to the customers. The customers can just order from that and buy our software, and it's all fully qualified. Now, if the customer says, I want to use a different SSD or I want to use a different server that's not on our list, then we qualify it, that configuration. Because you just want to make sure like the BIOS and everything is working well together. We qualify it, and then they can use it. And the qualification takes days.
Okay, yeah, because at the moment there's a lot of product substitution going on in the channel and supply chain.
Yes.
So.
And we provide that flexibility that, if they can get better terms from Micron versus Samsung, no problem, use Micron.
Another question.
That's your own algorithm to reorder the writes, because it's not random, and it's the intelligent flash management, I imagine. You've got the algorithm that reorder the writes to become sequential.
Yes,
Yeah.
yes, exactly.
So another question I have. So because you have this algorithm to reorganize the writes and everything, can you then use consumer grade SSDs instead of enterprise SSDs? Because if you provide 20x the endurance than a traditional vendor can, then why not using consumer grade SSDs that are
As long as it's NVMe SSD, we can work with it. We just need standard NVMe. Now, there has to be a server that supports that particular SSD, right? So if the customer is buying a server from a server OEM, typically in their server offerings, they don't have consumer grade, but they have lower cost QLC flash, for example, that customers are not using for these type of high performance applications, but we can make it possible to use that for this type of application. And by the way, that's another source of TCO reduction for us, is you don't have to use the expensive SSDs. You can use the cheap QLC flash and still get pretty good performance because of our software.
Okay.
Which, by the way, you look at the major storage OEMs do not have this. So they cannot improve the endurance of the SSD and get the TCO benefits of that because they don't have this software. And this comes from the fact that there's part of our engineering team built the very first NVMe controller in the industry at a previous company. So we have a lot of flash management experience in the company. If you think about the experience of the engineering team, it comes from flash management. We have a number of people also from Mellanox and other companies that have a networking background, because the whole NVMe over TCP, there's a big networking component to that. How you do multipathing and HA across the network is important. And then the third piece is just storage, data services. We have people who worked at other storage companies which have a long history of working with customers with various storage use cases. Is there another question?
I was just wondering what type of NVMe form factor is typically being deployed. Is it your M2? Is it your
We can work with
disk?
any of them, but the customers still are using a lot of the 2.5-inch drive form factor. But we've had people test us with the ruler form factor. Any NVMe SSD works. From the software, Lightbits software point of view, where as long as it's standard NVMe,
I was just wondering which way it's starting to go, but still the 2.5 inches.
we still see a lot of that because the standard server vendor offerings, if you look at what Dell has, HP has, Supermicro, Lenovo, it's still that form factor. There are some ruler form factors, and I think over time we're going to see more of that. because of the density it provides. And we've tested with those. We have no issues. We've tested with OCP platforms with 32 drives. And so, but in terms of what we're seeing customers actually use, it's the 2.5 inch. Now, if you look at hyperscalers, they have their own, some of them have their own SSDs. You can imagine who they are, right?
So, because you manage, the flash memory, so can you change the personality of the drive? I mean, some vendors, flash memory vendors, provide, the ability to change at the firmware level some characteristics of the drive, including, adding more space instead of adding, better endurance, for example. So
Yeah.
can you take advantage of that 10-20% of the drive?
So the answer, from a technical point of view, we could, but we decided not to do that right now because we're going after the mass market. We don't want to be tied to any particular SSD. So we want to go to a customer, so you can use any NVMe SSD. You can use any server vendor. You can use any CPU. We lead with Intel, but you can also use AMD. So for that reason, we have not done additional optimization with any particular SSD vendor. Theoretically speaking, the answer is yes. And if we have a customer that says, I really want you to get that last 10%, we could do it because we have the software layer that, what we can do is you can even turn off the FTL in these SSDs if you wanted to and just run everything from here. But that is not something that we're offering today. It's today, our approach is use standard SSDs, and with our extra, FTL, which is called Intelligent Flash Management, we do even better for endurance and performance.
And do you support the zones in the for flash vendors so to optimize the drive? So is it part of your intelligence?
Yeah, it's possible from architecture point of view. It's possible to support zones. But again, it's pointing to a niche of the market of specific SSDs that support this feature in NVMe
It's
standard.
not part of the standard, right?
It's part of the standard, but
It's
not
new, but it's
every
part
SSD supported today. So if you want the large scale data center SSDs, not all of them support. So we can support it in the architecture, but again, it will narrow our market of NVMe.
So you kind of lowest common denominator on those. You work for the lowest common denominator.
We go after the mass market. So we're going after, I would say lowest common denominator, but I would say we're not going after the niche, which is specific to, unless if a big hyperscaler says, I want you to optimize for my SSD and get the most, we'll do it. Because we have the mechanism to do it. But today, our production product, which is what's actually running in production, is designed to be able to run on any server, any NVMe SSD, as long as it's NVMe, that's all we need, and any Ethernet TCPIP network. So we don't require any special features on the network side. Every innovation we've had with respect to NVMe over TCP that impacts the client side, we contributed to the community because we want the client side also to be standard. We don't want any proprietary software from Lightbits running on the client. So our focus is just on the target side to make it easy for customers to deploy Lightbits at scale.
Can you give an example? You said that you said anything impacts the client, you contribute. Can you give an example?
Like for example, ANA capability, which supports multipathing, and maybe you can. We are, so when we introduced NVMe over TCP, we contributed our client driver to the community. And then we upstreamed it, and we're maintainers of it. ANA was added to provide multipathing on the client side. And all the work we did there is part of the standard client driver.
I can give another example for the NVMe side of the SSD side. Probably you know that in AWS, they have their own SSDs. They manufacture their own SSDs. And when we start the support for AWS, something we are going to launch in a few months, the software, the first time we executed the software on AWS, it runs. with no problems. It's different SSDs. It's not the standard Intel. It's different and it works out of the box, okay? Because we made things standard, per the standard of the NVMe. And if we would have used specific features, so it wouldn't work. Okay.
Okay, I'm impressed by this, but silly question, do you ever lose against your competitors when you come up against them? And if so, why?
I think our biggest challenge is that this is a transition. You know, customers, if they are using direct attached storage, they have a certain operational model around that. And now they have to move to disaggregated storage. So their whole management orchestration, everything needs to move to disaggregated storage.
So it's a cultural thing. It's the culture of the organization is impacting its move.
And there's work to do, right? There's work to do to make this shift. They see, so what happens is they do a POC, they see the value, they're like, wow, I can save money, I can get better economics and in some cases better performance. But then, and they start deploying this. It takes time to move their entire infrastructure to this model because it's a major shift for them.
But this is because you are talking about this high performance application that 10 years ago, 20 years ago were not there because storage are a network.
Correct.
You know,
It wasn't designed for
you have
this.
a new protocol, but actually it's a storage of a network. So,
Yes.
so they started using direct attached storage and not storage of a network because they thought it was more advantage from the performance point of view of the single one.
And that's why they started using direct attached storage because they couldn't find a SAN solution or disaggregated storage solution to meet that performance requirement. And so that transition from direct attached storage to us takes time.
And also, you've got to presumably change the mindset. There are people in these organizations that know how it works at the moment and are very skilled at this. And however good you are, if you move to a new paradigm, they may have more things to learn, or they may not be as employable in that under that new paradigm as they were before.
Yes.
So change always has to be managed.
Yes.
One
Now, the good
opportunity for you is we're seeing a shift to managed infrastructure.
Right.
Things like HP with GreenLake, dealt with Apex.
Right.
So one of the arguments would be you'd probably be best served almost to go in with them where it's a managed delivery and the aim is for the service provider to be able to deliver as efficiently as possible to make their money so they can push that transition. But then you've also got to try and get them to turf their storage out as well because they're trying to sell bucket loads of Electras or power stores and things like that in their deals.
That's a good point. I mean, we are, at this point, we're trying to be as agnostic as we can when it comes to underlying hardware to give that flexibility to our customers. We are offering both a node-based licensing scheme and a consumption-based licensing scheme because the consumption-based is what the CSP model, cloud service provider model, that even enterprises, some of them think that way and want to move in that direction. But back to the question, I think the transition to the cloud model is already underway. We line up well with that. We align well with that. So any of our customers that say, for example, we have a big New York City bank right now using Lightbits. We have a big financial and media company in New York, a big hedge fund company in New York. These are all enterprise companies, but they are building clouds internally. This is not replacing their traditional IT infrastructure. This is a new infrastructure that they're building, which is not that different than what Amazon or Azure is doing, but it's in-house and it's servicing multiple teams internally. And for that infrastructure, they don't want to use the traditional model anymore. They want the cloud model. So those are the type of application or use cases that work really well for us, and because the customer's mindset has already changed. They're ready for this new model already. But if you go to a customer and they're using like old, legacy SAN solutions to move them all the way here, it's a little bit harder.
Well, I guess you always want to have a business benefit to justify the expense of change.
Yes.
So
Yes.
you don't change where everything's going normally, you change when you're doing something new.
But there is something new for the customer to spend. So if you buy the DAS solution, you don't have to separate the software from the hardware. So you from a software point of view, have a perpetual license for whatever that DAS is doing. So what you're asking people to do is have another budgetary item, which is a subscription to
Right.
what you're doing. So it is complicating the budgeting for storage.
Yes, it's another item, you're right. The issue with DAS, it boils, and this resonates very well with anybody who's using DAS for high performance, is that you have this constrained ratio of storage to compute in every node. And as you scale, you're scaling storage and compute together. What customers are telling us is that they're only, in aggregate, using less than 20% of the available storage capacity when they have DAS at scale. This is a big pain point for them.
Which has been true for decades.
Yeah.
Even with SAN and so on.
But now, well, SAN is still shared, but DAS is not shared. It's constrained. You know, you have a certain ratio of storage to compute, and if you only want to scale your storage, you have no way of doing that. So what happens is, yes, they get performance, but they have and this problem becomes much bigger as you scale. If you have a small deployment, it becomes it goes under the radar. But when you got hundreds or thousands of racks, then it really shows up as a big issue. So this is the perfect fit for us to go in and say, we get you similar performance, but you get much better utilization, which means lower cost, and you get HA, and you get data services. So this is a great fit for us.
It's a cloud model storage array. Because the story that you're telling is almost exactly the same story that the array providers were telling, say, 10, 20 years ago.
Yes.
You know, connect all of your systems to this, give them access to this pool of data and so on. You're telling the same story, but with to the 21st.
But it's software defined,
late 21st
and it's for
century.
cloud.
Yeah,
It's for cloud infrastructure, right?
Yeah.
These are some of the comments from our customers. This one I'll show you in a second, a slide on FITS, which is a German cloud service provider. This is a large online travel company that said, on standard server hardware, Lightbits outperforms the most expensive flash arrays in our infrastructure at a fraction of the cost. This is from a big financial and media company in East Coast, US. They looked at they're building a cloud. By the way, these guys, the way they came to us is they called up Facebook, said, can we compare notes on how you're building your cloud? And Facebook said, you should go talk to Lightbits because we've been working with them on NVMe over TCP. And so they came to us and said, all right, we want to build a cloud. And they looked at all kinds of options, including NVMe over RDMA. They picked NVMe over TCP. And once they picked NVMe over TCP, they picked Lightbits because we not only had the complete storage solution, it's not just about NVMe over TCP. It's about all the features, the clustering, and integration with OpenStack and Kubernetes, which they're using for application orchestration.
Sorry, how many customers do you have in total?
We have tens of customers that are paying customers, and these are large customers. So we're not talking about small, these are banks. There's three categories of customers that we have today. Number one are cloud service providers that are building, and today they're the tier 2 cloud service providers that are building infrastructure and services for other companies. Number two are financial. We have a number of large financial customers who are building internal clouds. And number three are other enterprise private clouds. And now we're adding to this Lightbits on AWS, which Ophir will talk about in a second.
So can I play the advocate level here for a second? So you already have secured 54 million in funding, and there is another funding coming in. You're talking about tens of customers. That means 20, 30 customers. We did 50. You're talking about large-scale providers. There are a very limited amount of them, and very few niche use cases. what is your exit strategy here? Because, you know, a part of acquisition from one of these huge companies, but we have seen Accelero already going to, what was it, AWS, another one that was doing something similar. I mean, not exactly similar, but playing in the same high performance, very software defined kind of stuff. But so if we look at the rest of the market, even the pure storage of this world, they secured 10 times what you got, and they are still struggling to be profitable after 12 years, and they are playing the real mass market, because you are not playing the mass market. So you say, I'm playing for the mass market, but actually it's not. You don't have the duplication, you don't have erasure coding. So the problem is that for 99% of the users, you know, a general purpose workload is what they are looking for, so not very high performance, and then they look at economics, usability, etc., etc., etc. So I'm really missing here, you know, I mean, even though I really like what you do in the backend architecture and everything, what is the final goal?
Yeah.
Because you
Great
are
question.
not going to rule the world.
Great question. So the markets, the obtainable market for us, we've done a pretty detailed analysis. We reviewed it with all the investors, including the ones that came in this round, is about 10 billion in 2025. This is includes public cloud, private cloud, and edge cloud. So it's a pretty big market. And we have limited that to high performance and as well as the cloud model and just software. So it's a pretty big market. Now, the customers that we are working with today, each of them is tens of millions of dollars in opportunity size. Could be 50 million, depending on the size, depending on which customer. So we are going after customers that need to build large-scale clouds, whether as a cloud service provider for other companies or internally for themselves. And you know, they have anywhere from 100 petabytes to even exabytes in some cases of capacity in their internal data centers that is available. A portion of that is available to us. So it is a big market opportunity. And like I said, we have a detailed market analysis, and trust me, investors are scrutinized it with all
Okay.
and they chose to invest in us. And we'll share the names of the new investors and the size of the funding. And by the way, in this current climate where it's actually difficult to raise money, I think it's a pretty big validation of our value proposition that we're getting this new funding.
Is there an application change linked to your success? So for instance, you say high performance.
Yeah.
But what about, you know, container-based computing is increasing, so are you particularly good for that? If we ever get to automated vehicles, we're going to have an awful lot more data centers, and they're going to have very high performance in them. So are there some assumptions about the way the world will change in the next sort of 10 years that would affect your success in that way?
Yeah, the assumption is that there is a shift. So we took the way we did the market models, we started with TAM for each of these segments, public cloud, edge cloud, and private cloud. We took out anything that's low performance, anything that's hardware. So the underlying assumption is that there's a move to the cloud model. That's number one. And there's a growth of data. That's number two. And then the other ingredients that are required to support a solution like ours is already in place, which means high core count CPUs, plenty of networking bandwidth, everybody has Ethernet TCPIP, all of this is already in place. Like 10 years ago, you couldn't do this because 100 gig was expensive.
Well, I was looking at the server market in 2000,
Yeah.
and we had the same arguments against VMware, which was, well, why would you want to virtualize Intel servers when you've already got all these things from HP and IBM and Digital or whoever it was at the time,
Right.
but do these things much better than it'll ever work on Intel for the next 10, 15 years.
Yeah.
But it happened.
Yeah. And we have, to your earlier point that you made, we support Kubernetes environments. We have CSI plugins for Kubernetes. We support VMware. So if a customer wants bare metal, OpenStack, Kubernetes, or VMware, we support it. So we make it as easy as possible for all these different environments to be supported, as well as multi-tenancy. So all these features come together. So for customers building a cloud, and they need a high-performance block storage service, we got the best solution for them, which is also easy to deploy at scale. That's how we come in. Now, if you look at some of the other companies you mentioned, none of them had NVMe over TCP, by the way. Their architecture was centered around RDMA fabric, which is very difficult to build at scale. Also, they didn't have the intelligent flash management capabilities that we have. So yes, there were other NVMe fabrics stories out there that weren't as successful. But I think we have the right combination just based on the customers that we have today that are scaling with us, as well as the partnerships that we have, like with VMware and Intel. I mean, Intel, in fact, maybe I should just share with you very quickly. Intel has a massive partnership program with us. They have a large dedicated team of engineers working with Lightbits to help us with validating our solution, optimizing with the Intel CPU and Optane and Intel NIC, as well as doing ecosystem development, joint marketing, etc.
How many customers do you expect to have in 10 years' time? When you talk about mass market, you've got 10 customers at the moment.
Well, that's a very good question, because as soon as we release our offering in AWS, the mix of customers is going to change.
Yeah.
It's not just going to be the big enterprise customers, it's going to be a lot of little customers. So
yeah.
I can't give you a number, but I think the addition, it's not a pivot, it's the addition of Lightbits on AWS, and after that Azure will open up a whole new set of customers to us that today we're not servicing.
Yeah, I mean, it seems to me that you could be looking at thousands of customers, or even more if you're associated with people like Intel and so on.
Yes.
Will you be able to cope with scaling to that?
VMware has hundreds of thousands of vSphere customers.
But managing 10 customers is easy. Managing thousands of customers might be harder.
Right. Well, let me, from a go-to-market point of view, so far in Lightbits history, we've had a direct sales model and a relatively small team. In this new phase, we are building up our channel program. We have a program called Go Purple. We're going to have channel partners around the world, in addition to server OEMs and partners like Intel, who also help us on the sales side. So we're entering a new phase for the company because the product and the ecosystem is much more mature now, that we are opening it up to a much broader customer base. And that's why we waited until now to have our offering on AWS, because we wanted enough customer traction and deployments to be ready for sort of the bigger market.
So it's not a technology problem. If you do have problems, it might be managing partners like AWS, managing people like Microsoft. It might be the business side of things scaling up, which causes trouble. The technology seems to scale up okay.
Yeah. It's
support will be one of the most
support
critical
is,
elements.
and as the product becomes more mature and we have more of a self-service model for the cloud, support model is also changing, right? So we can address more customers. I apologize. I know we're really short on time. It's great questions. That's why I want to make sure Mark has time to go through his slides and we can talk about AWS. So Mark, maybe if you could go quickly.
Yeah, sure. So thank you everyone. Some great questions, by the way. I've been enjoying listening to them and the answers. So
feeling glad I'm not up to these.
yeah, definitely. So I've got just 2 slides, and then my colleague over here is going to go through some of the more technical side of VMware. Might whiz through it because I know he's very keen to see the demo. Very keen for you to see the demo. I saw the demo out all this morning, and to get over 1 million IOPS on 3 nodes was very impressive. So I'm hoping you guys will see the same. So Lightbits and VMware, we're, I guess the key thing on this slide, as far as I'm concerned, is that VMware are in partnership with Lightbits and NVMe over IP, over TCPIP is now here, which is, I think, really a great thing. So I just wanted to talk you through the journey we've been going through with NVMe. So we start on the left here. We started with Fabric over Fibre Channel and RDMA, and now TCPIP is here, which is what we've all been waiting for as far as I'm concerned. So universal support is kind of the main point as far as I'm concerned. No dedicated hardware required. And that to me is what will really see some momentum on this technology as we go through, which is what I'm really excited about. It's really easy to use. It's not on the notes, but I've started looking at it myself now. And what I like about the technology when it's embedded into VMware, when you use it within vCenter, is it's really, really easy to use. It's just a quick plug-in into vCenter, and then all of the functionality is there. And you'll see some of that in the slides coming up. Some nice features around snapshotting and very quick ability to do clones, which I see as a potential use case for maybe disaster recovery, to be able to clone data stores to another site, as an example. I see that's something really nice and will hopefully offer value to some of our customers. Performance we've already talked about. You're going to see a demo on the performance in a second, but the performance is, in my opinion, eye-watering. 1 million plus IOPS on 3 nodes at a very, very low latency at a very, very good price point. Scale up, scale out. We've already discussed that. And I guess encryption as standard, which a number of our customers, certainly the big banks, as we've heard, it's emission. They have to have it basically. So that's built in. I guess really, in conscious of time, I want to give you guys access to the demo. Any questions? If not, we'll hand over.
I think this looks good, but how would you position this against, say, vSAN versus moving with this type of solution?
vSAN, to your point and your colleague's point earlier on, is that kind of generic workload, mass workload. If you have a niche use case for high performance, then this would be it. You're not going to get the kind of performance that this delivers today out of vSAN. So if you've got
vSAN's also not that scalable in terms of its cluster size support and things like that.
It has a 64 node limit. I'm not sure, to be honest with you, what the node limit is here, but I would suggest the more important thing, and to your colleague's question earlier on, would be around performance. You can get the scale, you can get the performance.
Cache disk is the bottleneck of the writes.
Sorry, what was that?
The cache disk is the bottleneck of
Yes.
the writes.
Yeah.
So you need more disk group, but still the cache disk is the bottleneck.
Exactly, yeah. With vSAN, yeah.
So is Lightbits integration as good as we expect? The vaults and VASA providers and everything, integration with vRealize, whatever, all the components, or is it just
Yeah, please, yeah.
big words?
So today, our solution is based on VMFS. vVols is not yet available on NVMe over TCP from the VMware side. When it is available, then Lightbits will support it, yes.
And you're going to use a storage policy to decide the application factor of, for example, 2 copy, 3 copy of one single VM.
Yes, so maybe Ophir, if you can. So Ophir is going to go through a couple of slides and then maybe cover this very quickly because I want to make sure we have time for AWS.
Yeah, maybe we move on to the next slide.
We've got 5 minutes, guys.
Okay.
A couple of extra ones.
Go on there.
Why don't we jump to AWS?
Yeah.
So let me just say that Lightbits was a day zero storage partner for NVMe over TCP introduction from ESXi. We've been working with the engineering team for 2 years. Anytime there's something new capability offered with respect to NVMe over TCP, we will be there again as a day zero storage partner. And today we're the only certified software-defined storage with VMware that supports NVMe over TCP
So
as a software product.
Did the VMware sales team get a target or incentive to position this and sell it?
Today, our work with VMware is around the joint marketing and on the engineering side. Because VMware takes a neutral position in terms of supporting various different storage options. But we've had customers that wanted to use our solution. We required VMware support, and they jumped in and they helped us close the deal. So let's, I'm going to skip a lot of these slides, and you will have these slides, so you can go through them. So Ophir is going to give you a summary of what's coming on AWS.
Okay, so basically I was involved in Lightbits in the technical side from day zero. So I will just expose a few of the things. It's not all the information, and probably we couldn't cover it later on or when we actually going to public with this solution. From a compatibility point of view, you're talking about on-prem solution, and now we're going to be also on the cloud. And AWS is the first one. So we work on any AWS storage instance. For example, a month ago, there was a new instance launched, I4I, a new type of instance. So our solution worked out of the box with this new instance, and even with higher performance than with the i3EN. And we are working with any client instance, which is not trivial at all, because even the native storage cloud solutions, and I won't mention names, some of them, the high performance one, requires specific clients on the client side in order to use high performance volumes. So with Lightbits, any client, even a very weak clients, will get very high performance. We support VMware, Kubernetes, OpenStack, all the on-prem infrastructure we support also on the cloud. And all the data services that we are supporting on the on-prem also available on AWS, and even some new features that are not possible on-prem, because on AWS we have another orchestration layer of AWS. I will mention CloudFormation, which enable us to provide even more more automatic features, especially in the areas of deployment and auto-scaling and auto-healing, which we are bringing now in the cloud and specifically in AWS. We've seen this diagram of storage on a lot of slides, so here it is again. And what we are trying to tell here is it's so simple to deploy in AWS, and everything is the same concept, but even more simple to deploy. Okay? So if you have a VPC network where you deploy as an AWS customer, when you deploy your workload, your clients, your instances, so we are kind of mixing in with the storage into these VPC. Everything is connected internally in your VPC. Performance is super high. It's same as on the on-prem. We already tested it. And the cost of the traffic is zero, because it's in the same VPC. And when I'm saying cost zero, it's, again, in a native block storage, it's not zero. It's super expensive. Let's move on. So how do we enable this? We enable this lower cost and performance through efficiencies of compression, SIEM provision, we talked about it, unlimited and flexible snapshot and clones. Again, snapshot, every snapshot for high performance storage in native block storage, native cloud block storage. It can be AWS, it could be GCP, it could be Azure. It's very, very expensive. In Lightbits, in our model, it's unlimited and it's free of charge.
Are you actually building this infrastructure out in AWS and being, say, it's your service within AWS, or is this running on AWS's own nodes with your software?
Running on AWS instances with our software within the customer's VPC.
Yeah, so it's Amazon own hardware. You're not actually putting.
Yeah.
Yep.
Correct. Yes.
And which availability zones are you going to be deploying in?
So the instances are, initially it's going to be i3 and i4i,
Yeah.
which are both Intel, and Graviton.
Yeah, but that is on, just to be clear, it's on
That's
Amazon's
their own
own
instances,
hardware.
yeah.
You're not putting anything in
So I
yourself.
think it's
Just
two instances that the customer needs to, on which the customer needs to deploy your solution, right?
Yes, so the customer,
Actually, you're providing a cloud formation, I missed probably something. So
Yeah.
cloud formation.
I will get to it exactly in the next slide.
yeah, but,
Yeah.
but just
availability zones.
when you launch, how many availability zones are you going to?
So basically, we can deploy in a single AZ or multiple AZ. We are not recommending multiple AZ deployment, simply because of performance and
Yeah,
Right.
but most
I would-
companies
I would say
will
performance,
require
but you
multiple
got it.
availability zone solutions so that they can have resiliency, etc. Not that they want it to interoperate, but they need separate availability zone deployments.
there is solution for how to replicate the data in multiple availability zone, but in terms of high performance storage, you wouldn't want to do this kind of replication between AZs, between data center. It's slow and it's super expensive in AWS. Performance, it's what's matter here. So there's a lot of persistence within the availability zone itself, within the data center.
But in Europe, you can pretty much guarantee, unless you've got a few availability zones here in Europe, they're not going to be buying from the US
We want to talk
availability
about
zone.
backup to S3 as well.
Basically, we can run on every AZ out there in the world. Okay, we tested by today with 6 or 7 different regions. Each one of them runs 3 or 6 availability zones. We tested them. It works on all those areas. Okay, but we did test everything because AWS is huge. But eventually we will run in every AZ out there in the world. In Europe, we tested in US, I think it was tested in the Germany area. In US East, US West, North, South, Asia Pacific, we tested a lot of areas and it works basically everywhere. Okay? Let's move on.
Gentlemen, you've got about 3 minutes. Make them count.
Okay.
You want to jump to the demo?
Yeah, so just to say, to explain how easy it is, the demo will show you also, from the point you're entering the marketplace, probably you're familiar with the marketplace of AWS, there is a product called Lightbits. You won't see it right now because it's limited right now, but from the point you click to the point your storage infrastructure is ready to be used, it's 15 minutes. Of course, everything is on your account, belong to you. 15 minutes, even if it's 1 terabyte or 1 petabyte, it's the same time, 15 minutes. That's amazing with AWS.
So we need 15 minutes, is that okay?
Can you decommission?
Can we decommission? You mean decommission instances?
In 15 minutes.
Yes. Imagine you're deploying in a client
Yes.
environment and
Yeah.
you don't want to
So-
use it anymore. Do you need to to copy all the data and to copy back?
So basically, we have a feature that is available only on AWS. It's called auto-scaling, which means we take the amount of instances that you actually require. We are not based on a provisioned, but on actually used storage. Okay? This is a major feature on AWS. So we are both scaling up and scaling down the instances as much as needed. Okay?
But my question is more if you want to stop the service.
Can I interrupt 1 second? In the interest of full disclosure, Olivier is here to represent SNIA, the Storage Networking Industry Association, and totally independent. However, Olivier also has a day job working for IBM, correct?
Okay.
Before you answer anything, I just wanted to make sure. Full disclosure, guys. Sorry, Olivier, I didn't
It's
mean
okay,
to
it's
do
okay,
that.
no problem.
Thank you.
I just feel...
I keep my question though.
So can you repeat the question?
So the question is, how do you decommission if you want to tear down the cluster? How does that work?
To tear down the cluster is either in marketplace or through CloudFormation. It just tear down the infrastructure. It's
So
like,
you lose the storage basically, right?
Yeah, of
You
course.
need to copy your data before you do this.
Of course.
You can back it up to S3.
Of course.
Sure. I just wanted to understand.
Yeah. You can manually tear down whatever you want. You are the owner of the account, so you can go to the AWS console and perform any operation you like. If you will tear down an instance of storage, so the software will automatically try to launch a different one to back to the same replication level. Okay? You can kind of fight against the system.
She wants to see the demo.
Shall we move
Okay.
to the I
Do you have
dying to see the
it?
demo.
I don't have it here. Do you have it over there?
Yeah.
The quickest
Do you have a
demo
Wi-Fi?
in the world.
Do you have Wi-Fi?
I have a Wi-Fi, but it's better to...
So while we're getting that going, any other questions we can answer?
So in terms of, say, data destruction when the service ends, how do you do that? Is it key-based encryption, or do you have a secure wipe process when the customer decommissions and moves out of your environment?
Ophir, you want to comment on how we secure the data when something is decommissioned so that the data is destroyed?
Basically, there is the replication of the data within the cluster, and if you're losing instances, so auto-healing will bring back instances and recover.
Another question is, how do you get rid of the data when something is decommissioned?
Oh, basically, you cannot control this in AWS, because when AWS take the server, you won't get it back. Okay?
Absolutely, but just understanding, so how is that data
There is
destroyed?
a feature called the SED, self-encryption drive. So basically, if the storage is taken out, you're protected. But anytime the AWS, if you're returning a storage instance to AWS, so if you're not doing it in ordered way, so you cannot protect the data. But if you're doing it in order, if you're turning the storage down gracefully, okay, or you kind of unsubscribe the feature, everything is wiped. If you do it abruptly, okay, you will say, no, I want to take it by myself. And so there is no way, because it's controlled by AWS. We are going to see a demonstration of marketplace deployment.
Hi, welcome to this short video on deploying Lightbits cluster on AWS using the AWS Marketplace. My name is Roy Adiel and I'm a solution engineer here in Lightbits Labs. In this demo, we'll use the AWS Marketplace to deploy a Lightbits cluster, connect to the cluster, add our job token to the LBase CLI command, and then create volumes and connect them to a client. Let's begin. We'll get started by going into the AWS Marketplace and searching for Lightbits. Here we have two options. Let's choose the Lightbits Cloud Block Storage and pick that up. On this page, we have information about the product and the ability to subscribe. Let's hit subscribe. We'll get and accept the terms and condition. We can see the different instances that we can deploy, and we'll accept the terms. And now we'll wait for the subscription to pass through. This should take a minute or two, and while this is done, we can continue to configure the deployment. We'll hit configure. We have the fulfillment option, what software version we have to choose, which region we want to use, and some additional information. We'll hit continue to launch. And we'll choose how do we want to launch it. At the moment, we are using CloudFormation. Once we've launched this, we get into create stack through CloudFormation. So the YAML file is pre-filled here. We'll hit next. We'll give the stack a name. And here we'll add additional information. The region, we'll add a connectivity CIDR IP address, the amount of Lightbits clusters instances that we want to deploy, what is the instance type, we need to choose a key pair, and a region. Also, we need to add a bucket name for the Lightbits configuration to be stored at. So I'll add the bucket name. And the final setting is creating the network range for the VPC. I'll hit next. I have an option here to set up roles and tags and so on. I'm going to skip this for now. I can review the information that I've created, and I need to go to the bottom, acknowledge the creation of resources, and hit Create Stack. Now I'll go into my stacks and I'll see that CloudFormation is starting to create Lightbits with a predefined stack. So if I'll refresh, I'll see that it will start creating the network, and then it will create the EC2 instances for Lightbits, get it all together, and bring it up. In the meanwhile, while this is running, I'm going to go and create a small client so I'll be able to access this later. I'll go to EC2, and I'll launch a new instance here. I will choose an AMI that I already have. Micro will be good for this sake of test. So I'll choose the right network, and I'll choose the right subnet. I can define if I want to have a public IP address. Let's enable this in this case, and see that the rest of the settings are fine. We'll hit next. We'll add storage. It doesn't matter. This is local storage. Just choose the default. We can add tags to it. And then we do have to choose the right security group, so we'll be able to access that. I'll review launch and choose the right key again. And hit launch instance. So my instance is coming up. Let me go back to the CloudFormation to see what's going on, what's the status. I see that the network creation is completed. It's now continued to create. And in about 15 minutes, we're going to have a working cluster. Now we can see it start to create the EC2 instances and deploy the Lightbits cluster. If we'll go to EC2, we'll see that we'll have new devices that are initializing, and we'll be able to see them in a few minutes. We can also see the instance that is just created, still initializing. So here are my 3 new instances for Lightbits being created. Okay, while this is initializing, let's connect to the instance that I've just created and start preparing it to connect to Lightbits. So we can see that we have the NVMe TCP enabled on this client. And if we'll do NVMe list, we'll be able to see that there's nothing here at the moment. LSBLK will also show us that there's only one local device. There are no devices mounted. Let's go back to see what's going on with our stack. Still creating the EC2 instances. We'll be able to see that on the EC2, it's still initializing one of the nodes and the other 2 have passed. Once all 3 are up, it will start configuring Lightbits. Now that we see that everything in the stack has been completed, we can go and log into one of the nodes of the Lightbits cluster. Let's go to the EC2 instances. Let's just choose one of those nodes. And we can use Session Manager in this case to connect. So the first thing that we want to do is go and get the JOT in order to put it in the LBCLI. Now we'll edit the LBCLI YAML file. And at the end here, we'll add jot, colon, and paste what we've copied, the jot. We just have to be careful to see that it's actually one line. After we did it, we can save this file and get out and do LBCLI list nodes. If the jot have been inserted properly, we should be able to see the 3 active nodes that we have on the Lightbits cluster. Let's capture one of the NVMe endpoint devices for later usage. And now let's create our first volume to attach. We'll do that by doing LBCLI create volume minus project name equals default minus name equals vol1 minus ACL for the access control list. Let's call it client1 minus size equals, this is thin provisioned, let's do 1 TCPIP minus compression equals true. And lastly, minus replica count equals 3 for 3 copies. This have immediately created one volume. Let's just quickly create another volume. Let's call it volume 2 and change the size for 2 terabytes. Now that we've completed this on the Lightbits cluster, let's go back to our client and connect that into Lightbits. I have a service called Discovery Client that I can use in order to connect. And the syntax is connect all minus T, TCP for NVMe over TCP, minus A and the IP that I previously copied, minus Q with the ACL, which was client 1, and minus P for persistent. Once I run this, of course I forgot to hit sudo at the beginning. Once I've done this, the client will connect via NVMe TCP over the network to the cluster, and if I'll run NVMe list now, I see that I have those volumes that were created available here on the client. I hope you enjoyed this short video tutorial. For more information, please visit www.lightbitslabs.com. Please refer to the administration guide on our website for more information.